Good morning, everyone. Today I'm going to continue our study on the inference in first-order logic. And today I'll talk about the widely used logic programming language Prolog. First, I will introduce what is logic programming, and then I'll talk about the conventions and things you need to pay attention to when you use the Prolog language. And then I will introduce the two execution mode of Prolog, the interpretation mode and the compiled mode. And then I'll talk about the parallelism strategies of Prolog language, which is used to improve the efficiency of the execution. And finally, I'll talk about the drawbacks of this language. Logic programming means that the system should be constructed by expressing the knowledge in formal language, and all this knowledge is written in a file. And then the problem should be solved by running inference processes on the knowledge. And Prolog is used to express, is a kind of formal language to express the knowledge in the system. Prolog program can only express a set of definite clauses. And here are some examples of Prolog notations. We can see that in general, this language is opposite to what the first order logic use. In particular, we can see that the direction of implication in first order logic and Prolog language is opposite. Here is an example of the Prolog program. It is a recursive definition of the append operation. We can see that it includes assertion and the implication. And the whole definition is implemented in a recursive way. What is powerful about Prolog language is that it describes a relation that holds among the arguments. Like for example, if we want to know what two lists can be appended to give this the list here, we can just write the Prolog query in this way, and the result will return, and all the lists that can be appended to give the list there will be shown. And here are something we'll have to pay attention to when we use the Prolog program. First, the clauses are tried in the order in which they are written in the knowledge base. And this is the source of one of the Prolog's disadvantages, as I will describe later. And second, there is a set of built-in functions for arithmetic, such as multiple, minus, adding, etc. And no further inference will be performed on them. So this kind of sentence, 5 is x plus y, is illegal in this language because the built-in functions will not do arbitrary arithmetic solving. And the occur check is omitted for the Prolog unification procedure, and the Prolog uses that first backward chaining algorithm with no check for infinite recursion. This is the second point of his drawback, as I will describe later. And finally, the execution of Prolog program can happen in two modes: the interpreted mode and the compiled mode. And on the common interpretations, the Prolog interpreter have some improvements. First, it maintains a stack of choice points to keep track of the multiple possible matchings of inference rules in the OR procedure. we recall that in the backward training there is a OR procedure and there is an AND procedure. And what the OR procedure does is to find a rule that whose conclusion match the inquiry or match the goal. But there are times we have to, there are multiple possible matchings, and we have to manage all these possible matchings in a way. And the Prolog interpreter manage these matchings in the way of a stack, so that if one matching fails, it is simply pop out. 2. Instead of explicitly constructing substitutions, the Prolog has logical variables that remember their current bindings. And the bindings of variables are maintained in another stack called trial. And as each new variable is bound by the unified variable operation, the binding is pushed onto the stack. And when the goal fails and it is time to back up to the previous choice points, we do not pop out everything. We say only the variables that are unbound are removed from the trial, so there are some remaining variables on which we can continue our inference. And what are something we can call advantage of compiled mode over the interpretation mode? Of course, we usually see that the compiled mode, the interpreter of Prolog acted as if it has never seen the program before, but it just taking the Prolog program file and scan each rule one by one and perform inference. But in the compiled mode, the Prolog language sentences are converted directly into program. So the Prolog program will directly know which sentence to choose once the query comes in. Here is an example of the compiled program. We can see that the Prolog program, the definite clauses have been converted into if-then choices, so that we can see that execution efficiency will be greatly improved. And here are some points of the compiled procedure. In the compiled mode, the clauses become a procedure, and the inferences can be carried out by simply calling the procedure. And the first step of the procedure saves the current state of the trial, as we shall see in the program here. It saves the current state in the trial of trial. This line, yeah, this line here. And if each clause fails, the current state is restored by the reset trial sentence after the clause, which will undo any binding of the previous course of unified operations. And there is a data structure called continuation, which implements the choice points. It defines what should be done next whenever the current goal succeed. So when the current goal succeed, the data structure will be invoked, and all the work that need to be done when the goal succeeded will be done, as we shall see. In the program called continuations. Yeah, here and here, continuation. If either of the clauses succeed, the continuation data structure will be invoked. And one of the best ways to improve efficiency is through parallelism. There are two kinds of parallelism, the all parallelism and the n parallelism. The all parallelism comes from the possibility of a goal unifying with several different rules in the knowledge base. You see, for one goal, there may be multiple rules that match the goal. And we can carry out the matching in parallel to improve the efficiency. For the n parallelism, it comes from the possibility. So when we try to break the sentence into first and rest, which is what the n procedure does. It involves communication between branches because as a whole, they should construct a global solution. So when we are trying to extract each conjunct out of the premise of the implication, each of these branches should communicate with the other branches, which is the most difficult point of n parallelism. And then next I will talk about some drawbacks of Prolog language. The first is the infinite loops. We have an example here. Please write down these two. There are two logic. Actually, they're the same. Yeah, they're the same. But problems occur in Prolog because the Prolog scan these sentences one by one in the order in which they are written in the knowledge base. I'll show you how the problem happens. Wait a minute, I'll turn the camera. Okay, we have two logics here. For the first logic, which is this one, wait a minute, I'll see whether it's clear in the camera. No, it is not. I simply put it larger. Put it larger, yes. Make it larger. works. Okay, and then I H here. Okay, so what is the search tree for this logic program? If we want to, if we have three nodes, and we already know that these two nodes are linked, and we want to prove that there is a path from A to C. So how do we prove? The search tree, we want to prove there is a path from A to C. So the interpreter will scan the first sentence to see if A and C is linked. Obviously not. So the interpreter will scan. It will try to scan to see if A and C is linked. Obviously not. So the interpreter will continue to scan the next sentence to see if there are two pairs of nodes. Oh, sorry. Yeah. To see if a substitution can be found. I check if it is covered in the camera. Okay, no problem. And for this node, the recursion will go deeper. And in the next layer, the interpreter will again scan the first sentence. And it finds that there is a substitution that can satisfy the implication. So the recursion terminates for this branch. And in the same way, we can find a substitution for the variable here. So the whole recursion terminates and a proof is found. In this case, the Prolog program works properly. Okay, I'll check if these notations are covered in the camera. Okay, no problem. But for the second logic, it is a different case. Okay, what is the second logic? do is to reverse the two sentences. And what happens if inference is carried out in these sentences? Okay, we start from the goal. We want to prove the same thing, okay? If you don't remember, there are three nodes, A, B, C, and we have the goal. The goal is we try to prove A and Z. And then the interpreter will scan the first sentence and get these two lines. Then, when the interpreter will try to find an appropriate substitution for the newly assigned variable y, so it goes one layer deeper and scan the first sentence again. This time, the variable becomes this. You see, the variable y is different because of the standardized operation. And the program will try to find an appropriate substitution for y pi and y. And the recursion will continue, and the problem of infinite loop will occur. That is the problem. So, we should be careful when we write Prolog program to avoid this problem. Let's turn the camera back. We see that the Prolog program has the problem of infinite loops because it used the backward training algorithm with no check for infinite recursion. But for the other algorithm, the forward training algorithm does not suffer from the problem because after a certain number of facts is generated, the algorithm terminates. And we can see that when these three facts are generated, the program terminates because the goal is reached. Another disadvantage of Prolog is that it can suffer from redundant computation. And what this problem happens, we can see the example in page 343 in the textbook, figure 9.9b. And if we apply forward training algorithm instead, although the number of the sum of computation is still very large, it is still smaller than those of the backward training algorithm. And what improvements can be made? We can adopt the idea of the dynamic programming and catch the solutions to sub-goals as they are found, and reuse the goals when sub-goals happen again. And this is the strategy we try to use to avoid the redundant computations. The Prolog uses the database semantic, which is different from first-order logic. So it applies the unique name assumption and the closed word assumption. But there is one small problem. There is no way to assert that a sentence is false in this language. For example, if we write these 4 sentences and we say that there are exactly 4 causes. Under the unique name assumption, there are 4 distinct causes, and under the closed verb assumption, there are exactly 4 causes and no other causes. But if you want to implement this idea in first-order logic, it will be extremely complicated. Let's see how to do it. For first-order logic, first, we have to say that there are at most 4 causes. So here. And then we have to say that there are at least 4 causes, and which results in this line. So we can see that the database semantics makes the Prolog language extremely concise. Okay, that's all for today. Thank you. 关。